Here's a problem that asks you to find all zeros of a polynomial function, and it's not clear exactly how to do this, so we've got to be very careful here. First of all, the first thing I'm going to look at is, can I factor it? Well, it's got 4 terms. I don't see any perfect cubes or anything like that, so my first inclination would be factor by grouping. I can pull an x squared out of each of these first terms, so I'd get, I believe, this 2x times x squared gives me 2x cubed. And if I pulled the x squared out of this, I'd get the plus 5. So there's my first group. The second group, though, I don't see anything here. So actually, factoring by grouping isn't going to work. This is what I'm left with, just that second half with no factoring at all. So this doesn't help me. Factoring by grouping will not help me find zeros because of this plus sign. If this was a group on its own and this was a multiplication sign instead, that would have worked. But this whole situation isn't going to work. Okay, so what do we do then? Okay, well, we've got to look at the graph and figure out what we can do. Okay, so let's just take a look at what a graph might look like and actually plot some values on a t-chart. Okay, so none of this worked. All right, so let's go back to the drawing board and let's just have a look at this function here. Okay, let's just have a look and see what this looks like. Let's do a little t-chart here. Okay, so over here, I'm going to go x and y. When x is 0, y is what? 0, 0, 0, and a minus 2. So when x is 0, y is a minus 2. Okay, right there's our y-intercept. What about when x is 1? With these functions, even if big numbers are there, it's usually easy to find what they're equal to. If x is 1, then this whole term is 2. 1 cubed is 1 times 2 is 2. 1 squared is 1 times 5 is 5, plus 1 minus 2. 5 and 2 is 7, 8. 8 minus 2 is 6. So at 1, it's 6. It's pretty high, okay, up here compared to the rest of the graph. 1, 2, 3, 4, 5, 6. It's way up here. Okay, so let's try a minus 1. At minus 1, I'll get a little bit messy here. I'm going to erase some of this stuff here. Okay, not forgetting that point there, though. All right, at minus 1, this is going to be x cubed alone is going to be a minus 1 times 2, give me a minus 2. Minus 1 squared is 1, so 1 times 5 is a plus 5. Okay, minus 1 for x, it's got a plus in front of it, but it's a minus 1 here. Okay, and then minus 2. So what's that all equal? Minus 2 plus 5 is a plus 3. Plus 3 minus 1 minus 2 is 0. So at minus 1 is 0. That's critical. So at minus 1, I've got a root. And this is critical. I know it's a cubic, and so it's going to have a couple of points. There's probably another root somewhere out here. Or it could be going down like this and up like that. But since it's a positive, I think, since remember what y equals x cubed looks like, it goes up to the right and down to the left. So even though this one will have a bit of a bubble in it, I think it's going to look something like this, go down and hit here and come up and then go like that. Okay, so there's another root out here. How do I find that? And what's this root in here? How do I find that? Well, the answer is that you take the one that you found, or x plus 1, and we're going to divide it now. Okay, so I'm going to go over here and I'm going to do my long division. 2x cubed plus 5x squared. Okay, plus x minus 2. Sorry for the pause there. I had to go find the problem. And I now know that x plus 1 is a root because I found this intercept. When x equals minus 1, remember that x minus that intercept equals one of the roots. So that's where I get my x plus 1 over here. Okay, so now I'm going to divide all that stuff through and get this polynomial here. I don't need to go do the long division again. You've learned that already. But what I do get here is 2x squared plus 3x minus 2. Okay, and so now what we know this polynomial looks like is it's got an x plus 1 term, and then it's got this other term, 2x squared plus 3x minus 2. Okay, and so what we get here now is, is this part here, the second part, is this factorable? Let's see. With a 2, I'm going to have a 2x here and an x here. This tells me they're going to be plus minus, and I'm going to put the plus over here because I got a 2 there. I'm going to guess that the minus will go here because these things have to multiply to a minus 2. Well, it's got to be a 2 and a 1. That's all I can have. And so if I put a 2 there, I'll get a plus 2x times plus 2 is a plus 4. And a minus 1 there gives me a minus x. Okay, plus 4x minus 1x gives me the plus 3x. Look, it does factor. Factors beautifully. I already knew that this 0 was going to be x equals minus 1, right? Set this equal to 0. And you get x equals minus 1 as one root. When I set this equal to 0, that'll be 2x minus 1 equals 0, or 2x equals 1, or x equals 1/2. Okay, so there's one root. This one here is going to give me x equals minus 2. So there we go. Let's go back to our graph. Here's our three roots. Okay, here's our three zeros. We already had the minus 1. We knew there was going to be 1 on the other side, in the positive side of x, and we knew there was going to be 1 on the negative side further to the left than this one here. So let's go back to our graph. Okay, this looks like it's going to be a minus 2 in here, so it'll be much more over here than where I first estimated. Okay, and this one here, remember what I said, it was going to be 1/2. Okay, so there we go. This one's going to touch around 1/2. That was a good guess there. And the cubic is probably going to look something like this. Goes through 1/6, that point there, goes through 1/2 0, goes down here and hits there. I don't know if it actually turns there, but then it's going to come up here and turn like that too. I could evaluate it at -1.5, but why? The main thing they wanted me to find was all the zeros. So they didn't even have to find out what the graph looks like, but certainly the graph helps me understand what's going on here. Okay, so there's an estimate of what the graph would look like. But anyway, that's how you find all the zeros. You had to just play with a t-chart here until you found one, and then you had to do this division down here, okay, to get your other roots. And this thing factored nicely once you had this root here. Okay,